Hi class. Today we're going to be focusing on section 2.2, which is calculators and trigonometric functions of an acute angle. So let's get right to it. So they started us off with the definition of 1 degree is a complete 1 over 300. It's 1 over 3/60th of a full rotation. And we can break that down even further. If we divide 1 degree into 60 equal parts, then that is called 1 minute. And the way you denote a minute is with this little apostrophe. That means a minute. And 1 minute is 1/60th of a degree. In other words, there are 60 minutes in 1 degree. All right. So you got 60 minutes is equal to 1 degree. And equivalently, 1/60th of a degree is equal to 1 minute. And then you got 60 seconds is equal to 1 minute, just like in time. Just like with time, and equivalently 1 over 60th of a minute is equal to 1 second. All right, so let's see how this works. So we have an angle that is in degrees followed by minutes, and this one is also degrees followed by minutes, and we need to add them. So the way we add them, we can kind of stack them like we would with the normal numbers. When we're adding two numbers together, you can stack them vertically. And if you add this like you normally would, you would get 15 here, carry the 1, that's 4, 5, 6, 7 minutes. Over here, the degrees, that would be 10, carry the 1, that's 11, 12, 120 degrees. And because we know that 60 minutes is equal to 1 degree, so 1 degree is equal to 60 minutes, then we can take 60 of these minutes and convert it into 1 degree. So what that would do is that would add 1 degree to the 120 that we already have. And then if you subtract 60 minutes from 75, you get 15 left over. All right, so that's the way you would add two numbers that are in degrees and minutes. Decimal degrees. All right, now we can go backwards in the opposite direction. We can go from decimal degrees to degrees and minutes. And so what you want to do is you want to find out how many minutes is represented by 0.25 of a degree. So the way you can do that is you would just multiply the decimal portion, which is 25 or a quarter, times the 60 minutes, because it's not going to be the full 60 minutes. It's only going to be a quarter of the 60 minutes. So you're multiplying the decimal by 60 in order to get the number of minutes. So this is going to be 0.25 times 60, which is 15. So that gives you 15 minutes. So 0.25 of a degree is equivalent to 15 minutes. So we still have the 27 degrees. That does not change. The whole number stays in degrees. The decimal portion becomes 15 minutes. And that is your final answer. All right, let's take a look at this example. So here they're just asking you to find that value, so you can just use your calculators. So you would make sure that you're in degree mode because of that notation. That little circle in the upper right corner denotes that we're in degrees. So just use your calculators, type in tangent of 58.75. So that would be tangent of 58.75. And I am getting 1.6. I'm going to round to 2 decimal places, so it's 1.647, so I'm going to call that 1.65. All right, so that would be all. All right, let's see. All right, so that was it. Let's look at the homework for this. So once again, I'm going to skip over these definitions and these drop-down menus and just go right into the addition problem here. So just like we did in the notes earlier, I recommend that you stack these vertically when adding them, and just add them like you would regular whole numbers or decimals or whatever it may be. So that's going to be 7. That's going to be 4, 5, 6 minutes. That's going to be 17, 3, 4, 5, 6, 67 degrees and 67 minutes. And because this is more than 60 or more, you can convert this into 1 degree. Since 1 degree is equal to 60 minutes, that means we can add an additional degree over here that becomes 68 degrees. And then if you subtract 60 from this, that's going to leave us with 7 minutes. So that would do it, 68 degrees and 7 minutes. All right, now when you're subtracting these kind of values, this gets a little tricky here because there's no minutes to subtract from. So what you want to do here is you want to actually break this down into 89 degrees, 89 degrees and 60 minutes. Because 60 minutes is 1 degree, therefore this is really the same thing as 90 degrees here. We just rewrote it in a different way. All right, and now the reason we do that is so that now we can subtract 31 from the degrees and 15 from the minutes. And that's going to leave us with, let's see, how many minutes is that? I think that's going to be 45 minutes and 58 degrees. All right, so that's how that works. All right, in order to convert from decimal degrees to degrees and minutes, remember what we do here. We take the decimal portion and we multiply that by 60 because we want to know how many minutes is represented by 0.85 of 60. So you take 0.85 and you multiply that by 60 minutes, always 60, and that will give us 51 minutes. So 0.85 of a degree is represented by 51 minutes. All right, so now we know that this is going to be 98 degrees and 51 minutes. All right, let's look at the following problem. Change the following to decimal degrees. This time we're doing the opposite. They're giving you degrees and decimals. The degrees and the minutes. This time we want to represent this as a decimal degree, decimal degree. So instead of multiplying by 60, we're going to do the opposite. We're going to divide this by 60. So your answer should look like 72 plus 54 over 60. All right, so if you type that into your calculators, you should get, and then they also want you to round to the nearest hundredth place. So the hundredths would be 2 decimal places. So let's see what that turns out to be on our calculators. 72 plus 54 divided by 60 is 72.9. So you would just write 72.9 in this case. You could actually add in a 0 here because they want 2 decimal places, so I would add that 0 there. All right, so that's how you would do that. All right, next, use a calculator to find the following. Once again, notice that there's a degree symbol there. Therefore, you want to make sure your calculator is in the degree mode. And then go ahead and just type that into your calculator. Sine of 28.4 is 0.475. Round your answer to 4 decimal places past the decimal point. So I am getting 0.47562. And since they're asking for 4, you're supposed to check the 2. And since that is less than 5, we're going to keep that at 6. 0.4756. All right, more calculator problems. So when you get something like secant, your calculator probably doesn't have secant. So what you can do is rewrite that as 1 over cosine. And your calculator does have the cosine button function on it. So make sure you take the reciprocal. So do 1 divided by cosine 47.1, close parentheses, and I'm getting 1.469. They want 4 decimal places again. 1.46903. So check. That's going to stay at 0. 1.4690. Same thing here, except this one, they are looking for the secant, just as before. But notice that they give us minutes, and our calculator doesn't handle minutes. We don't know. Our calculator doesn't know what to do with that. So we have to convert that to a decimal degree. All right, and the way we do that, remember, we divide by 60. So that's going to look like 1 over cosine of 45 plus 59 out of 60 degrees. All right, so if you type it in exactly the way I have it here on the calculator, you should get the right answer. 1 divided by cosine of 45 plus 59 divided by 60 I'm getting 1.4391. And they want 4 decimal places, so it should be 1.4391. All right. All right. Find theta if theta is between 0 and 90 degrees. So when you're asked to find the angle, in this situation, you need to take the inverse tangent of both sides. And that's how you get the tangents to cancel out. So you get theta is equal to the inverse tangent of 0.6791. All right, and make sure you're in degree mode, once again, because they want us to be in degrees here. So do inverse second tangent, and then 0.6791. You should be getting, I'm getting 34.18, and they want you to round to the nearest tenth. So that would just be 1 decimal place. So I'm getting 34.2. And just make sure that your angle is between the indicated domain, which it is. All right, same idea here. But this time, remember, our calculators don't have this function. They only have sine, not cosecant. So you want to take the reciprocal of both sides of the equation. So the reciprocal of the left side is sine. And the reciprocal of the right side would be, maybe I should write this out so that you can see what I'm doing. 1 over cosecant theta is equal to 1 over 1.6996. I'm taking the reciprocal of both sides of the equation. The left side becomes sine. The right side becomes 0.58837335. And now I can take the inverse sine of both sides. And when you do that, you should get 36.04, but they want you to round to the nearest tenth, which is just 36.0. That's what I'm getting. All right, and so that, once again, make sure that your angle is between the two angles that they want it to be between, which it is. All right, so let's see what they're asking for. They're basically asking us to verify or justify the cofunction theorem, because remember, these two are supposed to be equal to one another because these are complements of one another and these are cofunctions of one another. So you can verify that by actually just doing this on your calculator. So let's see, what is the sine of 24? Sine of 24 is 0.4 and round to 4 decimal places, so 4.067 is what I'm getting. And then the cosine of 66 degrees is 0.4067. And as you can see, these are the same. All right, for the final problem, what happens when you try to find A for this value? You should try that on your calculator. Do the inverse sine. Whenever you're looking for the angle, you're supposed to always do the inverse to find the angle. So you should get, if you try this on your calculators, you should get an error message. The reason is because sine, the highest value sine can take on is 1, and the lowest value it can take on is -1. So the answer will be an error message displays because the sine of an angle can never be greater than 1. So in general, sine of an angle is always going to be between -1 and +1. That's an important fact that you should try to remember. Sine and cosine, by the way, are always going to be bounded above by 1 and bounded below by -1. That's why this is not possible, because sine can't reach 1.298. The highest value it can reach is 1.